All right, let's look at the even and odd functions. Here's the definition. All right, so f is called even if f of negative x is equal to the original function f of x. And f is called odd if f of negative x is equal to negative f of x. Right? So you get the negative of the original function. Right? So let's look at the following three simple examples. Right? So let's check this one. F of x equals x to the fourth minus 3x squared. Right? You can pay attention to the power. Right? You can see that both powers are even. Right? So we think that it's going to be an even function. Let's see how it goes. So let's compute the f of negative x. Right? So using the function notation, every time you see x, we replace x by negative x. Right? To the fourth power, there's negative 3, and then you have a negative x squared. Right? Then you can see that, negative 1 to the fourth power is 1. So this is actually exactly the same thing as x to the fourth power minus 3. Negative x squared would be just x squared, right? So you can see that this is exactly the same function as the original function. So this is equal to f of x, right? So you can see that, so therefore, this guy is a even function. So I'll just say even. Right? How about the next one? Right? Next one might be a little bit tricky. So g of x is x cubed over x to the fourth plus 1. So we're going to compute g of negative x. Right? So this is going to be equal to, right? So every time you see x, we put the negative x there. So negative x cubed over, right, negative x to the fourth power plus 1 is still plus 1, right? So this is equal to, right? So negative x, so negative 1 cubed is going to be still negative 1, so it's going to be negative 10x cubed, right? And on the bottom, just like before, negative x to the fourth is x to the fourth, and then plus 1, right? So you can see that here, this portion without the negative sign is exactly the same as g of x. So you can see that this expression is negative of the original function, right? So according to the definition, this is an odd function, right? How about the third example? H of x is equal to x cubed minus 1. So you plug in negative x in there. Right, so you have a quantity negative x and raise it to the third power minus 1, which is really the same thing as negative x cubed minus 1. Right? So you can see that this is not the same as the original function or the negative of the original function. So these are not the same as h of x or negative h of x. Right? So which means that this is neither even nor odd. So this is neither. Right? There's another thing we want to talk about even and odd function. There's this symmetry attached to even and odd function. Right, so even function, when you plug in negative x, you get the original, same as the original function. So you can see that, for example, if you take some x value, right, take some x value, and let's just say graph goes through somewhere around there, right? So this is going to be, let's just say I'm going to put negative x, right? Then if you plug in negative x, you get exactly the same value. So it's going to be dot is going to be placed at the same height. So you can see another dot, right? And this is true for all x. So if you pick another point, so here and here, let's say this is going to go through at that point and maybe at that point. And if you take another x value and then this is negative x, you have same height on both sides. So let's just say the graph might look something like this. Right, so you can see that exactly the mirror image is happening about the y-axis. So when you have an even function, this is going to be a symmetric. So I'm going to say symmetric about the y-axis. Right? So if you have an even function, the graph is going to be symmetric about the y-axis. Right? So what if you have an odd function, right? So when you have an odd function, if you plug in, say, x, say the value is somewhere up here, and if you plug in negative x, you get the negative of the original value. So you're going to go same amount. So this is the same distance, but the other way, so negative side. Then you have a dot there, right? So when you have a point over here, and there's going to be a point over here. If you have a point over here, there's going to be a point over here, right? So as you can see that here, I'm going to just draw a picture. So it might look something like this. Let's see. Right? So you can see that this is symmetric about the origin, right? So which means that if you pick a point, and go straight to the origin, and if you go to the other side with the same distance, you're going to always find the corresponding point. Right? For example, if you pick a point here, go through here, go to the other side, you always find the corresponding point. Right? So when you have an odd function, the graph of an odd function is always symmetric about the origin. Right? So these are the symmetries we can say. So remember that if you have an even function, its graph is going to be symmetric about the y-axis. So you have a mirror image on the right and left of the y-axis. And if you have an odd function, its graph is going to be symmetric about the origin. All right, that's it. I hope that this was clear.